Hello Gems! Welcome to the first episode of mock test series. This series is specially dedicated to BITSAT, and in this series we'll be discussing one mock test per week for the rest of the days, whatever is left to us. And I think that will account up to 6 to 7 mock tests before the session 1 of BITSAT, and I believe it will help you a lot in your BITSAT preparation. So I invite you today to join me in this grind, and with that being said, let's begin with this video. So let's begin with the first two questions for the day. Here in question 1, we have a straight wire of mass this and length this. It is suspended in mid-air by a uniform magnetic field. It is also given that the wire is carrying a current of 2 amperes. Okay, I forgot to mention that formally in the question, but it was given in the question. Okay, so basically we have a wire which is carrying a current of 2 amperes. Okay, now of course the weight of the wire is pulling it down, mg in the downward direction, but the wire is suspended in air. It is hanging out there in midair. Okay, and how is this happening? Because we have a magnetic field. Okay, it's suspended by a magnetic field. What does the magnetic field do? It imposes a force on the wire, right? So that force is actually in the upward direction. Okay, this is the force due to magnetic field. There is a force due to magnetic field on a current carrying wire, if you remember. Okay, so this force will be in the upward direction and it will balance this mg. Again, that is why the wire is hanging in midair. Okay, so basically our fb, the force due to the magnetic field, will be equal to mg, and that is why our wire is hanging out there in mid-air. Okay, now it is easy to see that the magnetic field will be in the inward direction. Why am I saying so? See, the magnetic field, first of all, the force due to magnetic field is given as IL cross B, right? IL cross B, that is the force due to magnetic field. Okay, so we want the force in the upward direction. Remember that L will be along the wire, right? L will be along the direction of the current. Okay, so basically L is along this direction in the plane of the board, along this direction. Then we have B. If it's inward, then the force will be upward. Okay, so basically we are reverse engineering it. We want the force in the upward direction, so L should be along this direction and B should be inward. Okay, so force is upward, L cross B upwards, right? So B will be in the inward direction. Okay, now let's equate these two forces. So we have IL cross B or ILB sine theta equals mg, right? Because our wire is hanging in the air. So sine theta, if you see, L is along this direction, B is inward, right? L is along this, B is inward 90 degrees. Okay, so sine 90, that is 1. We don't have to worry about it. Now we have to just find B from this. All of the other things are given. So we have B equals mg. M is 200 grams, 0.2. G is, I'll take it as 10. Actually, we are supposed to take it as 9.8, but anyways, we'll get a close approximation. Then B I by L. Okay, so that is 1.5 length into the current, which is 2. So 1.5 into 2, that is 3, and 2 by 3. 2 by 3 is 0.67. Okay, so 0.67, and that is in Tesla. Okay, so yes, a close approximation, which is 0.65. We are getting 0.67 because we took 10 in place of 9.8. Okay, so yeah, option D, 0.65 is the correct choice over here. Let's come to question number 2 over here. We are supposed to find current I1 in this branch, the current I1 which is flowing in this branch over here. Okay, so first of all, let us try simplifying the circuit. Okay, so here we have 4 and 4 in parallel. That will make it 2, right? R and R in parallel makes it R by 2. Remember that. Okay, so 4 and 4 in parallel, 4 by 2, 2 ohms. Okay, so 2 ohms and 4 ohms in series, 6 ohms. Okay, 6 ohms and 4 ohms in parallel. Okay, we have to do that now. So R effective, 6 ohms and 4 ohms in parallel. Okay, so basically it's product upon sum. So 6 into 4, the product, and upon their sum, which is 6 plus 4, 10. So 24 divided by 10, 2.4 ohms. Okay, I hope you are able to follow. This makes it 2, 2 plus 4, 6, 6 and 4 in parallel, 2.4. Okay, now finally we have 2.4 and 1.6 in series. That will make it 4. Okay, so the effective resistance of this entire circuit, by simplifying it, is 4 ohms. Okay, I'll call this dash. Okay, so here we have the effective resistance of this circuit, which is 4 ohms. Now the current which is coming from this circuit, I can call it I. So I will be V by R, right? So V by R effective. Okay, so V is, the voltage is 4, resistance effective is 1. So the current which is drawn from the cell is 1 amperes. Okay, so 1 amperes is coming at this junction. Now it will split up, of course, into I1, and I can call this I2. So we have to find this I1 now. How will we find? Actually, there is a direct formula. Okay, you can see that, see, the resistance over here is 4 ohms. Okay, and the resistance over here is 2 ohms. This is 2 ohms plus 4 ohms. That is 6 ohms. Okay, so you can divide this current, which is 1 amperes, into this ratio 4:6. That will be, you can say, 0.4 and 0.6, right? And more, the maximum current, the greater current will flow through that path which has less resistance, right? So greater current through less resistance. So 0.6 will flow from here and 0.4 will flow from here, because here the resistance is less. So 0.6 will flow from this branch and zero point 0.4 will flow from the other branch, and that is what we are supposed to find. And so 0.4 is our answer. If you want to calculate it through formula, basically I1 is the total current, okay, resistance in the opposite branch, which is, I'll call it, okay, let's directly substitute. So the total current 1 into the resistance in the opposite branch, which is 4, divided by the sum of the resistances, which is 4 plus 6, okay, in the both the branches, which is 10. So this gives you 0.4 amperes. Okay, again, you can use logic or you can use magic or formula. Okay, yeah, so that is your answer. Let's move to next set of questions. So question 3 and 4 over here. In question 3, when we use a light of this wavelength, when it falls on a photoemitter, photoelectrons are just emitted. Okay. Then for another emitter of different material, we have to use a wavelength, different wavelength, which is 600 nanometers, to just liberate the photoelectrons. Okay. So basically these are threshold wavelengths. Okay. And you are supposed to find the ratio of work functions over here. Okay, the ratio of work functions of these two different material. Now it's very simple. If you know the formula for work function phi, so it is given as hc by lambda naught. Okay, lambda naught being the threshold wavelength. Okay, so here, of course, we are speaking of threshold wavelength. Where does this come from? It's very simple. You might know this equation, the Einstein's photoelectric equation. So the kinetic energy of the photoelectrons is h nu, okay, minus, which is the energy supplied by the radiation, minus your work function, right? So in the case where the electrons are just emitted, it means that they are just emitted with zero velocity or zero kinetic energy. Okay, they are just emitted. Okay, they don't have any kinetic energy. We can consider that. So in that case, kinetic energy is zero. So h nu becomes equal to phi. Okay, and in this case, this nu will be nu naught. Okay, in this case, it will be nu naught, the threshold frequency, the minimum frequency that is required to push out an electron, just to liberate an electron with zero kinetic energy. Okay, or you can write this as, the frequency basically can be written as c by lambda, or in this case, c by lambda naught. Okay, so basically it's the same thing. You can directly see the relationship between your work function and threshold wavelength. It's inversely proportional, right? So the ratio of work functions phi 1 by phi 2, okay, for material 1 and material 2, thus this ratio will be inversely proportional. Okay, so phi 1, lambda 1 over here, inverse relation, and lambda 2 over here, okay, inverse relation, right? So lambda 2 is 600. Yes, this is lambda 2, this is lambda 1, material 1, material 2. Okay, so material 2, what is the wavelength? 600, and here we'll have 300, so that is 2. Okay, so 2:1. Yes, 2:1 is the correct choice over here. Okay, let's come to this question now. A monoatomic gas is suddenly compressed. Now that's a clue. To 1/8 of its initial volume adiabatically. Okay, it's already given that it's adiabatic. Okay, so even if it was not given that it is adiabatic, you can make out, because it's said in the question that it's sudden, right? Isothermal processes are slow, adiabatic are which are suddenly done. Okay, so yes, it's adiabatically done. You are supposed to find the ratio of final pressure to initial pressure. Again, pretty simple. In adiabatic processes, you might know that PV raised to gamma is constant, right? So you can write P1 V1, or I'll write P initial V initial raised to gamma is equal to P final V final raised to gamma. Okay. Now we are supposed to find the ratio P final to P initial. So P final to P initial, that will be V initial. Okay. P final, yes, P final by V, yes. Okay, so V initial by V final. Okay, just take this to the other side and bring this over here. Okay, now gamma, now we are told that it is a monoatomic gas. Okay, and gamma for monoatomic gas, what is that? Okay, I don't know, I'll just use one. Gamma is 1 plus 2 by F. F for a monoatomic gas is 3, so it gives me 5 by 3. Okay, some of you might directly know the gamma for monoatomic gas. Yes, it's 5 by 3. So V initial volume, suppose we consider as V, then final volume is 1/8 of the initial volume, right? Final volume is 1/8 of the initial volume, so it is V by 8. Okay, and this is raised to gamma. Gamma is 5 by 3 for monoatomic gas. V cancel, 8 goes on top. Okay, and 8 raised to 5 by 3. Oh my god, what is this? Okay, it's actually very simple. 8 is nothing but 2 raised to 3, and we have 5 by 3. Okay, so this will basically multiply, and you'll have, okay, so you'll have something like this. Okay, this and this will cancel, 2 raised to 5, which is nothing but 32. So option A, 32 is the correct choice over here. So 2 simple questions. Let's move to the next set of questions now. So question 5 and 6 over here. In question 5, we are asked to find out the intensity of the magnetic field at the center of a single turn coil. Okay, so we have a circular loop which is carrying a current of 0.9 amperes. Okay, we are supposed to find what is the magnetic field at the center of this coil. Okay, it is given that the radius is 5 centimeters. Very simple question, because we directly know the formula for the magnetic field at the center. It is mu naught I upon 2r. Okay, if there were n number of turns, it becomes n times. Okay, so basically here the number of turns is 1. Okay, then let's find out. So directly substitute the values. Mu naught will be 4 pi into 10 to the power minus 7, right? Mu naught upon 4 pi is 10 to the power minus 7. So mu naught is 4 pi into 10 to the power minus 7. Okay, and that into I is 0.9. Fine. And then we have 2 times r, which is 2 times 5 is 10, and that is in centimeters. So let's convert that to meters. Okay, that is the case. 4 nines are 36, 3.6 pi, and then we have 10 to the power minus 7, and in the denominator it will become minus 1, so this will become minus 6, and again if we move the decimal, okay, it will become minus 7. Okay, I hope you were able to follow. Okay, you can just do the calculations, you'll arrive at the same answer, which is option A. Okay, pretty simple. Now this one is not simple. Let's see, a capacitor of this capacitance. Okay, and then it is connected with in series with a resistor of this ohms. Okay, this many ohms, it is 10 mega ohms. And mega is basically 10 to the power 6. Okay, mega is 10 to the power 6. You can remember million is 10 lakhs. 10 lakhs is 10 to the power 6. Okay, and then it is charged fully. Okay, so first it is charged through a battery, and then it discharges through the resistor. Okay, then we remove the battery, and now the capacitor is discharging through the resistor. Okay, you are supposed to find the time when the potential across the capacitor will fall to half of its original value. Okay, so basically you are supposed to find that time when the charge falls to half of its value, because basically the charge is C into V, right? So C is constant, so when potential becomes half, charge will also become half. Okay, which is obvious. Okay, now I doubt if you have studied this topic. This comes under transient response. Okay, it's in chapter 16 or chapter 2 of your 12th standard, electrostatic potential. There the equation for discharging is given as Q equals Q naught e raised to minus t by tau. Okay, Q is equal to Q naught e raised to minus t by tau. This is the equation for discharging of a capacitor through a resistor. Okay, now Q is the charge at a particular instant. Now we will find the instant t when the charge becomes half, right? Potential becomes half, which means charge becomes half. This is the original charge. So Q naught by 2, here we have Q naught e minus t, which we have to find, time we have to find. Tau in the case of a RC circuit, okay, tau in this case is nothing but CR, okay, so CR over here. Okay, so let's just solve this. So we have this half is equal to E raised to minus T by RC. E will be nothing but, so I'll just flip it over. Okay, so it will become T by RC is equal to 2, right? So minus sign goes because I flipped it over, reciprocals. And then we can take log on both the sides. So log E, I'll take log E. So T by RC equals log to the base E2. So okay, we are given some data also over here. Okay, now let's solve it further. I'll do it over here. So time we have to find, which will be RC into log E. Log E can be converted to log to the base 10 by multiplying 2.303, right? And this into log to the base 10 2, okay, which we know the value of. Okay, it's given in the question. R is 10 mega ohms. 10 mega ohms is 10 to the power 7. Okay, mega is 10 to the power 6, and into 10, that is 10 to the power 7. C is 0.1 microfarad. Microfarad is 10 to the power minus 6, and into 0.1, 10 to the power minus 7. So this efficiently cancels out, and we have these two things. Okay, 2.303 into what is that? 301.301. The answer over here will be, these two things will cancel. It will be 0.693. Okay, I know this multiplied by this is 0.693. Basically, you do it in one of the derivations, I think half-life. Okay, you multiply these two things and the answer is 0.693. Okay, so option C, 0.693 is the correct choice over here. Okay, it's from a very different concept. Okay, it's from the discharging of a capacitor, transient response basically. So I doubt if you know this topic, but please note down this question. Let's move to the next one. So question 7 and 8 over here. In question 7, it's again very simple. We are given an equation. F has the same dimensions as that of force. T has the dimensions of time. We are supposed to find the dimensions of A and B. Okay, it's very simple. You can see that these two terms are added. So this should have the same dimensions. Also, by principle of homogeneity, anything which is separated by an equal to sign, plus sign, minus sign, or any inequation of any type will have the same dimension. So basically F will have the same dimensions as AT, and which will have the same dimensions as BT square. Okay, so all three of them will have the same dimensions. Now force, we know that it is mass into acceleration. So mass into acceleration, these are the dimensions of force, dimensional formula I shall say. Okay, now from here we can find the dimensions of A. So it will be basically the dimensions of force divided by time. Okay, so we'll have mlt raised to minus 3, and here in case of B, if you see, there is just t square, so it is divided by t square, so mlt raised to minus 4. So mlt raised to minus 3 and mlt raised to minus 4. Okay, so option B is the correct choice over here. Yes, option B is the correct choice. Okay, yeah, that is simple. Let's come to question number 8 now. Here we have a glass, water and air interface. Okay, we have a ray which is incident at an angle I between the glass and water interface. Okay, the path of the ray is shown. Okay, the ray hits the water air interface and it is grazing emergence over here. Okay, so R is nothing but critical angle. Yes. Okay, and here we are given the refractive index of water. We are supposed to find the refractive index of glass. I have a faint memory that we did this question in a series as well. Okay, let's do it again. So here basically we know that R is critical angle. Okay, R is critical angle because we have grazing emergence over here, right? If the angle was greater than R, there would have been total internal refraction. Okay, so here we have R as critical angle. So the sign of the critical angle, okay, sign of R will be nothing but the refractive index, 1 upon the refractive index of the denser material. Okay, what is denser, water or air? Here the interface is water air, right? So denser material means water. Okay, denser one is water among them. Okay, so sign of the critical angle is 1 upon the refractive index of the denser material. Okay, so now what can we do? We know that so sin r will be basically 3 by 4, right? Can calculate that. Yes, so we calculated sin r. Now let's apply Snell's law on this surface. Okay, the glass water interface will apply Snell's law. Okay, so here I times, okay, it will be the refractive index of this material into the sine of incidence, okay, is equal to refractive index of the other material into sine of r. Okay, so refractive index of this material, the angle that it makes, the sine of that, and the refractive index of this material into angle that it makes. Okay, so yes, we have the Snell's law. So we are supposed to find the refractive index of glass. So it will be given as refractive index of water, which is 4 by 3. Sine of r is 3 by 4, and this is 1 upon sine I. Okay, we don't know the angle I, but it's okay. We are supposed to tell the answer in terms of sin I. So refractive index of glass is 1 upon sin I, option B. Okay, I think that was very simple. Let's move to the next set of questions now. So question 9 and 10 over here, let's get straight to it. In question 9, we are told that a body moves in a straight line by a constant power. A constant power is given to it, and then we are asked to find the relationship between distance and time. Okay, so the proportionality relation between the two. Actually, it's very simple. You are just supposed to write power as force into velocity. Okay, force is nothing but mass into acceleration. We have velocity over here, and let's express everything in terms of distance and time. Okay, so we have power on the left hand side, mass and acceleration will be L by t square, right? Change in velocity per second. Okay, so L by t square. Basically, you can also write it dimensionally. Okay, then velocity is distance by time, so length by time. And now let's take t to the other side, so we'll have pt cube equals ml square. Okay, now power is constant, right? Mass is also constant, right? Mass of the body will be constant. Power, we are told that it is constant power is delivered. So you can easily see that your length square is directly proportional to your time cube, or time cube is proportional to length square, or this is the relation between the two. Okay, distance square is proportional to time cube. Option A is correct. Now let's come to question number 10. Okay, now we have a simple wave. Okay, this is the simple wave, not that simple. And then we are supposed to find the resultant amplitude of this wave. If you see, you can see a combination of two SHMs, right? Two SHMs are added over here. Okay, so what is the resultant amplitude? It's basically, if you remember, it's same as vector sum, right? We treat them as phasors, so you can basically write a1 square plus a2 square plus 2a1 a2. Okay, 2a1 a2 into cos phi. So basically this phi is nothing but the phase difference between these two things. Okay, these two waves. Okay, SHMs. Okay, so here we have sine 4. Let's find phi first. Okay, sine 4 pi t, and here we have cos 4 pi t. If you see the difference, the phase difference between the two is basically pi by 2. You can write this cos as sine pi by 2 plus, or I'll write it as sine 4 pi t plus pi by 2. Okay, so this is sine 4 pi t, this is sine 4 pi t plus pi by 2. So pi by 2 is the phase difference between them, right? So basically you find the difference between their arguments, 4 pi t, and here we have 4 pi t plus pi by 2. So difference is pi by 2. Okay, so here the difference is pi by 2, and cos pi by 2 is 0. So this term basically is 0. Don't have to worry about it. So AR will be nothing but a1 square plus a2 square. Okay, fine. So a1 square, amplitude of the first wave. Okay, so amplitude, basically the equation is y equals a sine omega t, right, plus 5. Okay, so here if you see, a will be 5. Okay, so 5 is multiplied to both the terms. So 5 in the first case, so 5 square, and here we'll have 5 root 3. Okay, please don't forget the 5. So 5 square and root 3 square, that is 3. Okay, so again we'll have 25, and 5 square 25 into 3 75, 75 plus 25 100, 100 root 10. Okay, so 100, yeah, root of 100 is 10. So option D, 10 units is the correct choice over here. Okay, units were not mentioned, so yeah, It's in maybe in centimeters or meters, whatever unit. Okay, yeah, so option D is correct. Let's move to the next set of questions. So question 11 and 12 over here, let's get to it. So question 11 actually is a bit tricky. Okay, here we have a tank. Okay, now we have made two holes in this tank, one at a level y from the top level and one at a level 4y from the top level. Okay, now these two holes are different in nature. One is a square, okay, of length side L, and other one is a circular hole of radius r. Okay, you are supposed to find the value of this radius in terms of this length L. Okay, now it is also given that the quantity of the water that is flowing through these holes per second is same for both. Okay, so the amount of water that is flowing through each of these holes is same per second for both. Okay, so yeah, so how will we solve this? First of all, you'll get one clue from here. Okay, so quantity per second is same for both, which means they are kind of speaking of conservation of mass. Okay, so here also the thing that you are supposed to apply is equation of continuity. Equation of continuity you might apply in simple problems as well, like you might have seen it. Suppose the area over here is A1, velocity of fluid is V1, here the area is E2, what will be V2? So these are simple questions which are based on equation of continuity. Okay, but here it's complex. The two holes does not seem to be linked, although you can apply equation of continuity over here. So A1 V1 equals A2 V2 is the thing that you are supposed to use over here. Where is the clue? Clue is over here that it is speaking of conservation of mass. Okay, and continuity, the equation of continuity is itself based on conservation of mass. Okay, so let's solve it now. Okay, so first of all, v1 will call this hole 1 and we'll call this hole 2. Now what will be the velocity at 1? It will be nothing but under root 2gh, right? H in this case is y. Okay, so basically the speed of efflux, okay, it's 2gh, just like a freely falling particle, right? Provided the area is very much bigger than the hole. Okay, so yes, the area of this tank, okay, the tank area will be bigger than the hole. That is an assumption we are assuming. Okay, and v2 will be nothing but under root 2g 4y. Okay, so the level over here is 4y. Okay, so we have v1 and v2. Okay, so let's substitute them over here. Area 1, so we have a square of length L, so that is L square, area 1. Velocity in 1, so 2g, height is y. Okay, then we have area 2, which is pi r square, fine, and velocity in 2 under root 2g 4y, or I can write it as 2 under root 2gy, right? Yes, 4 will come out as 2. So this and this can get cancelled. What are we left with? We are left with L square is equal to 2 pi r square. Fascinating. So we are supposed to find r. R will be nothing but L by under root 2 pi. Okay, so the correct choice over here is L by under root 2 pi. Okay, so this is a type of questions wherein a question wherein you have to know it first in order to solve it. Okay, so you might it might not click you that the question was supposed to be solved. What am I saying? Okay, was supposed to be solved based on equation of continuity. Okay, anyways, let's come to question number 12. Here we are given the circuit. It is also given that this ammeter current is 0. Okay, so ammeter reads 0 because there is no current in this branch. Okay, so that is what is given, and we are supposed to find the value of this unknown resistance R. Okay, actually you can do this through Kirchhoff's law. Yes, but I think we'll use a logical approach over here. So basically they are telling us that there is no current in this branch, right? The current in this branch is 0. Why is it 0? Because the potential over here and the potential over here is same, right? That's why no current is flowing in that branch. Okay, so we'll call the potential over here as 2, basically because it's connected to the positive side of a 2-volt battery. So the potential on this side is 0. Okay, so 0 2, here the potential difference is 2. Okay, so here if the potential is 2, here also the potential will be 2. Why? Because there is no current flowing over here. The potential will be same. Okay, so 2, also potential over here will be also 2. Here also it will be 2. No resistor, inductor, anything. So as long as you don't have any circuit element, the potential will not drop across a wire. Okay, the potential will not drop across a conductor. Okay, so 2 2 2, no inductor, resistor. Here we have a resistor, so potential will of course fall. Here if you see, this is connected, this point is connected to the positive side of a 12-volt battery, will have a potential difference of 12 over here. Okay, so yes, this will be 12, this will be 0. Okay, so if you see across this what we can say, across this resistor, the current that is flowing is I. We can calculate the current which is drawn from this. Okay, we can write it as I is equal to V by R, right? We can write it as V by R. So V is first of all 12 minus 10, the potential difference across this, which is 10. Okay, 12 minus 2, potential difference, delta V by R. R is 500. Okay, fine. So this and this will get cancelled. 1 by 50, that is 0.02, right? So 0.02 amperes is the current that is flowing in this loop. Okay, now now if you see the potential difference across this resistor R is 2 volts, right? So 2 volts potential difference we have. So 2 volts, I is equal to, we know what do we have to find, R. Okay, so V is equal to IR. R can be easily found out using the potential difference is 2, the current is 0.02, R can be easily found, and it will be 100 ohms. Okay, yes, no current is going over here in this branch, so the current is only flowing over here. So entire 0.02 is going through this. Okay, it's not splitting up at this junction, the potential is the same, so it's going like this in this loop. Okay, so yes, again use V equals IR over here on this resistor, and you'll have your answer, and that is B 100 ohms. Okay, I hope that was logical and simple and you liked it. Let's move to the next set of questions. So question 13 and 14 over here. Question 13 is a bit trickier question. It asks you for the dimensional formula of inductance, which is denoted by the symbol capital L, and it is measured in Henry. Now, I call it trickier because L, if you see, you just can't use any formula. Okay, if you use any formula, if that formula has mu naught and other terms, okay, some complicated terms, then you should also know the dimensional formula of those terms, right? So mu naught itself has its own dimension, it's a dimensional constant. Okay, so that's why it becomes trickier. You can't search for a formula first, you have to think for a formula which will make the calculating the dimensional formula of inductance simpler. And I think the simplest formula is, you can actually pause the video and try thinking about it yourself. Okay, I'll be happy if you come up with an answer, and I'm going to spill my answer in 3, 2 and 1, and the answer is E equals L di by dt. Okay, this is the EMF across your inductor, right? It's minus L di by dt, but here you are just concerned about the dimensions. Now if you find any other simpler version of it, do let me know in the comment section. Okay, I'll cheer for you. And let's solve it now. So we have to find the dimensions of L. Okay, basically the EMF can be written as voltage per charge, right? QV equals basically QV equals the work done, right? So work done will be nothing but basically the voltage will be nothing but work done by charge. Okay, so here we'll have L di by dt. So now apply dimensions. So here we have work is force into displacement, or it will have the same as power. So not power, I mean energy, so mass into velocity square. Yes, charge is current into time, so A into T. Okay, fine. Then L, we have to find its dimension. Here also we'll have current. Okay, and di is current, change in current, that is current, and here we'll have dimensions of time. Okay, now let's try to solve this. So if you see, this t and this t will get cancelled, and we'll have in the denominator we'll have a square. A square, it will go on top as a to the power minus 2. So ml2 t raised to minus 2, a to the power minus 2, ml2 t to the power minus 2, and a to the power minus 2. You can basically remember the dimensions of work, and we have a to the power minus 2 if you want to by heart. Okay, Let's come to this straightforward question now. We are given that the maximum current that can pass through a galvanometer, this galvanometer has a resistance of 40 ohms. Okay, so this is given. The maximum current, which means it is the full scale deflection current, that is 10 milliamperes. Okay, it is converted into a voltmeter. Now we use a resistance R, which is connected in series to in order to convert the galvanometer to voltmeter, right? And the range is 0 to 50. So basically the maximum voltage that it can measure is 50 volts. Okay, so then what is the resistance that needs to be connected? Okay, so R, there is direct formula to it. What is the formula? R is V by the galvanometer current, the full scale deflection current, minus the resistance of the galvanometer. I've used Rg, right? So V is 50 full scale deflection current, 10 milliamps. I can write it as 10 into 10 to the power 3 over here. Okay, that goes in the top as plus. Okay, and then finally we'll have minus 50 minus 40. Okay, fine. This and this cancel. 5000 minus 40. I think I'm missing something over here. Yeah, it's correct. 5000 minus 40, that is 4960. Okay, yes, 4960 is the correct choice over here. Okay, let's move to the next set of questions now. So question number 15 and 16 over here, we are almost halfway there. We'll be only doing the physics section. If you want to do the chemistry and the math section of this paper as well, I've provided the PDF in the description box of this video. You can take the challenge and try the questions from chemistry and maths as well. The downside is that the number of questions are more. It's 40 questions. For physics, actually, I had very cleverly, I would say, based on weightage, I had selected 30 questions, okay, which we'll be doing now. And the rest of the questions from the other sections as well, you can do it from the PDF, okay. So yes, let's get to question number 15. For a given velocity, a projectile motion has same range for two different angles. Something should click you over here, okay. You are supposed to find and T1 and T2 are the time of flights for each of this projectile motions. Okay, so for two different angles, we have the same range, and T1 is the time of flight of this one, T2 is the time of flight of the other one. Then you are supposed to tell what is their product proportional to. Okay, R stands for range over here. Okay, so first of all, the thing that should click first to you is that for two different angles and for a given velocity, which means that if you think complementary angles have same ranges, right? Two angles which are complementary, by that I mean alpha plus beta equals 90. Two angles that add up to 90 will have the same range. For example, 60-30 will have the same range, 45-45, that doesn't make sense. So or else you can say 75-15, those also, okay. So basically two angles that add up to 90 will have the same range. Okay, we are speaking of the same range, okay, and the two angles that we are speaking over here are nothing but complementary angles. So if one angle is theta, other is beta. No, 90 minus theta. Okay, so these are two complementary angles. If you add them, the sum is 90. Okay, so first of all, we can write time of flight for the first one, which has angle theta. So 2u sine theta by g. This is the formula for time period, right? So T2 will be given as 2u. Here the angle is 90 minus theta. Okay, so 2u 90 minus theta sine theta um, by g. Okay, so here sine 90 minus theta cos theta. Okay, so 2u cos theta by g. Okay, now we are supposed to take their product. So T1 into T2. Okay, so here we'll get what will we get over here? 4u square by g square. Okay, fine. Sine theta into cos theta. Okay, now we have to express it in terms of r. Okay, r is u square sine 2 theta by g. Okay, we can take 2 sine theta cos theta over here. You can see, right? So that is sine 2 theta. U square also we can take. What is left out? 2 is left and g is left. Okay, these two are constants. You can see that. So u square 1 2 I took it inside, 2 sine theta cos theta, that will be nothing but sine 2 theta, and here we'll have 1g. Okay, so this is nothing but r, right? This is nothing but r. So we'll have 2 by g, which is a constant, and here we have r. So you can see t1 into t2 is directly proportional to r. 2 by g is a constant. Okay, so here t1 into t2 is directly proportional to r. That is your answer. Okay, this thing should click you that two different angles for a given velocity will have the same range if they are complementary. Okay, yes. Now, here a question on Doppler's effect, one of the favorite topics of BITSAT. So, a sound wave moving towards a stationary listener with 1/10 of the velocity of sound. You are supposed to find the ratio of the apparent frequency to original frequency. Now, it's very simple. Apparent frequency is given as, here you'll have something, okay? I'll tell you about that something, times the original frequency. I'll write it as O, okay? Now here we'll have velocity of sound minus or plus, the sign may depend. So we have observer over here and we'll have source over here. Okay. So basically if you see your observer, the listener is stationary, so we don't have to worry about this. Okay. Whether it's plus or minus 0, we don't worry about that. Now stationary is what about your source? Okay, source is moving with 1/10 of the velocity and is moving towards the listener. Okay, so what is it doing? It is trying to increase the apparent frequency. Okay, it's moving towards the your listener. Okay, so listener is hearing more waves, so the apparent frequency is increasing. Okay, so how will it increase? If there is a minus sign over here, apparent frequency will increase if the denominator decreases. Okay, some of you might directly by heart the formula when this is moving towards that, this is minus, that is, so that is confusing actually. Okay, you can think it this way. Okay, since the your source is moving towards the listener, it is trying to increase the frequency, right? So the denominator should decrease in order to increase the apparent frequency. Anyways, let's come back. So apparent frequency by original frequency, you can write it this way. So v minus v, this is v is speed of sound, and here we'll have the velocity of your source is 1/10 of the velocity of sound. So v by 10. Okay, so it's pretty simple. We will cancel throughout. 1 minus 1 by 10, which is 9 by 10, which is 1 upon 9 by 10. So that is 10 by 9. 10 by 9. Option B is the correct choice over here. Let me check that. Yes, option B is the correct choice over here. Let's move to the next question now. So question 17 and 18 over here. In question 17, we have a satellite which is moving in a circular orbit. It is at a distance r from the surface of the earth, not from the center. Keep that in mind. R is the radius of the earth. You are supposed to find the orbital velocity of the satellite. Okay, let's picture the scenario first so that we don't make any mistakes. So this is earth. We have a orbit. Okay, this is our satellite, mass small m. This is at a height. Height is measured from the surface and it is at a height of r. Okay, and if you see the distance from the center will be 2r. Okay, this distance is r and it is at a height of r. So this total distance is 2r. Okay, keep that in mind. Now some of you might directly know the formula, but I prefer using equating the centripetal force and the gravitational force. So mv naught square by r, so mv square by r equals basically the centripetal force or the centrifugal force equals the gravitational force. That's why the your satellite is revolving. Okay, so we'll have the gravitational force as gmm by r square. Okay, so again we can cancel some things, this and this will cancel. R, remember, is the distance from the center, not from the surface of earth. Okay, so this is the distance from the center, which is 2r, r plus r. Okay, so again one of the r's can get cancelled, I believe. So v naught square equals gm, you can very well write it as gr square. Okay, r being the radius of the earth. Okay, and we have divided by r square. Okay, now substitute gr square equals this equals what is small r? Small r is the distance from the center of the earth, which is 2 times of capital R, and that you square. So that will give you, am I missing something? Okay, this is not squared. Okay, this is just single r, and that will give you this r and r will get cancelled and we'll have gr by 2, and that is v naught square. So v naught will be nothing but under root rg by 2. which is option C. Yeah, that's correct. Option C, under root rg by 2 is the correct choice over here. Okay, let's come to question number 18 now. We have a stone of 10 kg. Let's simultaneously draw it. We have a stone of 10 kg over here, which is attached to a string. Okay, this has a breaking strength of 10 kg weight. Now this is kg weight means basically this is mass, and if you multiply it by 10, okay, you will get your the force. Okay, so it is 300 newtons. This is the breaking tension. Okay, at this much amount of tension your wire will break. Okay, this is the breaking strength of the wire. Okay, so basically kg weight, whenever you have kg weight, if you multiply this number by 10 or 9.8 precisely, you will get the force. Okay, so this is weight, kg weight, and if you multiply it by 10 or 9.8, you will get force. Okay, so this is the breaking tension that you can apply. Okay, that is the maximum tension that you can apply. If you apply more tension than that, your string will break. Okay, you are supposed to accelerate the stone. Okay, you want to raise the stone to a height of 10 meters. You are supposed to do it in such a way that the rope does not break. Okay, of course we have mg in the downward direction. Okay, so you can write F net equals ma. So T, the force in the upward direction, minus mg equals mass into acceleration, right? The force in the upward direction. Now we are raising it up, so T will be greater than mg. So T minus mg will be mass into acceleration. Okay, now we don't want to give an acceleration which will break the wire, right, which will break the string. We have to give a certain limit to the acceleration. Okay, and that limit we can find by equating the tension to 300. Okay, that is the maximum tension that we can apply, which means that we'll find the maximum acceleration that we can apply. If we pull it up with a greater acceleration, the string will break. Okay, so here let's substitute T as 300. Mass we know it as what is the mass of the stone? It is 10. Okay, 10 into gravity, again 10. Then we can write 10. Okay, mass is again 10 of the stone, and acceleration. Okay, so this is the maximum acceleration that we can apply. Okay, if we apply greater than this acceleration, a value greater than this acceleration, the string will break. Okay, so you can cancel 10 throughout. You'll be left with 30 minus 10, that is 20 meters per second square. This is the maximum acceleration. Okay, you are supposed to find the time, minimum time. Okay, yeah, that is the maximum acceleration, so that will give you the minimum time, of course. So you can find it using s is equal to ut plus half at square. Initially the stone was at rest, so half at square, u is 0. Okay, so t is basically 2s, t is basically 2s by a, right, under root 2s by a. So what is that? 2 into s. S is a distance of 10 meters, height of 10 meters, and by a, acceleration is also 20. Nice. So this and this will get cancelled. Under root doesn't matter, 1. Okay, so option B, 1 second, is the correct choice over here. Okay, so I think that was simple. Let's move to the next set of questions now. So question number 19 and 20. So question 19, how much of work should be done to move a block of 50 kg, a body of 50 kg mass with a velocity of 20 meters per second in 10 seconds. Okay, so first of all, work, we can easily write it as F into D, force into displacement. So F into S, and Fs cos theta basically. Basically, if you see the force, we are applying it in the same direction, and displacement will be in the same direction when we push or pull the body. Okay, so force and displacement are in the same direction, cos 0, 1. Okay, so yes, Fs cos 0, 1. Okay, so we don't have to worry about the cos factor. So here force we can write it as mass into acceleration, and here we'll write displacement. Okay, so first of all, we need to find what is the acceleration that we are giving to that body, and what is the displacement in 10 seconds. Okay, so it's actually very simple. Acceleration will be nothing but change in velocity. The change is 20, right? Final is v minus u upon t, right? The acceleration is change in velocity by time. So final velocity 20, initial is 0, right? So we'll assume that we are beginning at rest. So 20 by the time taken is 10. So acceleration is nothing but 2 meters per second square. Okay, so acceleration is 2. Mass we already know 50, acceleration 2, and displacement also we have to find. So S is equal to ut plus half at square, u is 0, okay, and half at square. A is 1 and A is 2, and t square. Time is 10 square 100. So the displacement is 100 meters. Okay, so displacement is 100. So 100, and this is also 100. 100 is 10 to the power 4, and the answer is in joules. Okay, so 10 to the power 4 joules is the answer over here. Pretty simple, right? Just use the formula and just find acceleration and S, okay, which is displacement. Let's come to this one now. The square of the resultant of two forces, two equal forces, is 3 times their product. Okay, then the angle between them is, okay. So first of all, we are speaking of the resultant of two forces. Okay, there are two equal forces, and they are acting in some weird angle, okay, at some random angle between them, and they are acting. So there is their resultant, okay. And some information is given about the resultant. You are supposed to tell what is the angle between the first two forces, those two equal forces, okay. So first of all, let's break it down. So the resultant, basically, if you see, is given as, if you remember the formula, the magnitude of the resultant, I'll just square both sides. So directly we'll have r square is equal to f1 square plus f2 square plus 2 f1 f2 cos theta, right? This is the vector formula for finding the magnitude of the resultant, if you remember, okay. Now, basically f1 and f2 are equal. You know that they are two equal forces. Okay, so here we are given that the square of the resultant. Okay, so this term r square. This is the square of the resultant, right? It is the square of the magnitude of the resultant. Okay, so the square of the resultant is equal to 3 times their product. Okay, 3 times the product of these two forces. So F into F, okay, which is F square. So this, I hope you are able to follow that. So I'll go again. So the square of the resultant R square is equal to 3 times their product. Okay, 3 times the product of these two equal forces. 3 times F1 into F2. F1 F2 are equal, and that is F square. Okay, so let's solve it now. So F square plus F square, which is 2F square, and here also we'll have 2F square. So I'm taking that common. So we'll have this term over here. Okay, F square can get cancelled, and we'll have 3 by 2. 3 by 2 equals 1 plus cos theta. 3 by 2 is 1.5. 1.5 minus 1 is half, and we have cos theta. So theta, cos of which angle is half. Okay, you don't have to look for general solution. Just think of an acute angle. Cos of what is half? Sin 30 is half, cos 60 is half. 60 is pi by 3. Okay, so option D, pi by 3, is the correct choice over here. That was pretty simple, I guess. Let's move to the next set of questions now. So question number 21 and 22. In 21, it's a question from SHM. You are given the displacement of a simple pendulum at a particular instant. It is this, and the acceleration is also given. You are supposed to tell what is the angular velocity at this instant. Okay, actually it's very simple if you know the formula, of course. The formula that you are supposed to use over here is the general equation of SHM. Okay, the acceleration in case of SHM is given as minus omega square x, right? And remove the minus sign because it just shows the nature of a and x, that they are acting in opposite direction. A is opposite to x. Okay, so displacement and acceleration are opposite. Okay, so here it's very simple now. Omega will be nothing but under root of a by x. So a is nothing but 0.02. Okay, sorry, acceleration is 2, and your a is 0.02, or I can write it as 2, and I can take 10 to the power minus 2 on top. Okay, 2 and 2 will get cancelled. Under root 100, that is 10. So 10 radians per second, option B. Okay, pretty simple. Now let's come to this one. It's based on an advanced concept wherein you introduce a slab, sorry, at one of the slits. Okay, so you are supposed to tell what will be the shift in the fringes. Okay, some of you might directly know the answer by heart, but it's actually very simple to do. Okay, so basically when you introduce a slit at one of the sources, at one of the slit, what happens is that there is a path difference that is created. Okay, so if I place a slit over here, okay, suppose here, okay, when the rays go from here and here, a path difference is created in the path of this ray 1. Okay, a path difference is created, and due to which when they meet at the center, okay, there is also a path difference, and they might not interfere constructively. Basically, the central bright will not be formed over here, it will be shifted some fringes up. Okay, and that is the question, by how much distance will all the fringes shift up. Okay, all of them will shift up a uniform distance. Okay, whatever the central bright goes up, all the other fringes will also go up that same amount of distance. Okay, so basically there is a path difference created over here, and that path difference is mu minus 1 into t. Actually, there is a small derivation behind it, and it will take a little bit of time. So just remember that whenever a ray goes through a slab, the path difference that is created is mu minus 1 into t. Honestly, I also don't know how to derive it at this point of time, so yes, please remember this. Okay, sorry. Now let's proceed with the problem. Now what we can do, we can say that the basically, if you want constructive interference, the pattern should be, the path difference should be n times of lambda, right? So this is for constructive interference. What am I saying? Okay, so when n equals 1, we have the central bright, right? So delta x equals lambda for n equals 1. So this is our central bright. Delta x, we know it as mu minus 1. The path difference over here is this mu minus 1 into t. Okay, where t is the thickness. Okay, and here we have this. Okay, so we know lambda. Now where will be our central bright? It will be given as lambda capital D by small d. Okay, this is the position where we have the central bright, right? N is 1 for central bright. Okay, so lambda is mu minus 1 into t, and here we have capital D by small d. So your answer is, so this is the distance that your central bright has shifted, otherwise this would have been 0, right? So yes, this is the distance that has been shifted, so it is mu minus 1 into t, or capital D by d, mu minus 1 into t, option B. Okay, so I know it was based on an advanced concept, and it's a very good question, okay, to remember. So let's move to the next question now. So here are 4 simple questions that I have grouped together. So let's solve them one by one. So sonography uses. So what type of waves do sonography use? Okay, so this is from communication systems. You are supposed to read your NCERT well, and from that you are supposed to know the basically the applications of different types of waves. So sonography uses your ultrasound. Okay, so it's a theory based question. I can't help you with any bit of it. If you don't know it, you don't know it. Okay, so then we have the rate at which a black body radiates energy is proportional to. So basically rate of energy, which is power by Stephen's law. You should know that Stephen's law is sigma a t to the power 4, right? So for a black body, the power radiated is given as sigma a t to the power 4. So your energy radiated, or the rate of energy radiated, or power, is directly proportional to the fourth power of absolute temperature. Okay, so yes, option D is the correct choice over here. Then coming to this question, a body moves with uniform acceleration. You're supposed to guess its graph. A versus t graph is given, acceleration versus time. So of course your acceleration is changing. Here it's constant. This may be the one. Here, yes, it's changing, it's also changing, so option B is the correct choice over here. Okay, pretty simple. Yes, then we have in elastic collision. Okay, so in elastic collision, the collision where they stick together and move. Okay, what is conserved is momentum and kinetic energy both conserved, only momentum conserved, kinetic energy conserved, or neither of them is conserved. Okay, here you might say neither of them is conserved, but remember that in every type of collision, always your momentum is always conserved. Okay, in any type of collision, momentum is always conserved. Okay, so momentum is conserved. Kinetic energy, of course, there is a loss, there is deformation, so yes, some amount of kinetic energy is spent in doing work. Okay, so yes, kinetic energy is not conserved. Energy overall is conserved, but yes, momentum is conserved. Okay, kinetic energy is not. Let's move to the next set of questions now. So question 27 and 28 over here. In 27, we are told that the ratio of primary to secondary number of turns in a transformer is 4:1. So you can see that the number of turns in the secondary coil is more. So it's a step up transformer anyways. If the current in the primary coil is 4 amperes, you are supposed to find the current in the secondary coil. Very, very simple question. So number of turns in primary to number of turns in secondary equals. Now there is a direct relationship between the number of turns and voltage. So you can directly write voltage in primary to voltage in secondary. Now for an ideal transformer, the relation between voltage and current is inverse. Okay, so here current in primary, here current in secondary, inverse relation. Okay, and that is true only for an ideal transformer. We are going to assume that it's ideal over here, although it's not mentioned. Okay, now number of turns, this ratio primary to secondary to primary is 4:1, primary to secondary is 1/4. Okay, we are not concerned about voltage. Let's see over here, current in secondary, that is what we are supposed to find. Current in primary 4. Okay, so 4 and 4 cancel. Current in secondary is 1 amperes. Okay, so option C, 1 amperes is the correct choice over here. Now question number 28, the minimum force required to move a body up on an inclined plane is 3 times the minimum force that is required to prevent it from sliding down. Okay, so first of all, let's talk about the other force, the minimum force that is required to prevent the body from sliding down. Okay, suppose we have a body of mass m, so along the incline the force is mg sine theta, right? So please remember, so if the angle of inclination is theta, which we are supposed to find, here we'll have perpendicular to the incline, it's mg cos theta, and along the incline it's mg sin theta. Remember that. Okay, now the force that is preventing this block from sliding down is nothing but the frictional force, right? Mu n. Okay, so here n is nothing but mg cos theta, right? These two forces are equal. Okay, that's why there is no vertical motion. So n equals mg cos theta, right? And this two forces are also equal. So this is the force, the minimum force that is required to prevent the body from sliding down. Okay, which is the frictional force. It's avoiding the body from sliding down. So mu n. So we'll call it F. Suppose. Okay, this is F dash. We'll call it because some other force is also there. So mu n. N is nothing but mu. It's mg cos theta, right? Now, the next force is the minimum force that is required to move the body up on that incline. Okay, so we are going to push that body up on the incline. Okay, this is the force that we are going to apply up the incline in order to push that body up. Okay, now mg sin theta along in this again along the incline, down the incline, and now the frictional force will be in the downward direction. Okay, here's the key point. Why? Because there is a tendency of upward motion. If you see in this case, the block wanted to slide down, but friction opposes relative motion, right? The tendency of relative motion. So it was acting in that direction. Okay. Now here in this case, we are pushing the block up. So there is a tendency of block moving up. Okay. So here in this case, the friction will act in the opposite direction. Okay. And minimum force means this 3 will be equal. Actually, this force should be greater so that our block moves up, but they are saying minimum, so we can equate their sum. Okay, so mg sin theta plus mu mg cos theta. This is the other force. Okay, so this force, the minimum force required to move the body up, this force which is required to move the body up is 3 times the force required to prevent it from sliding. So F, this force which is pushing it up, is 3 times the force required to prevent it from sliding. Okay, so we just have to solve this equation now and we'll have our answer. Okay, so F, what is F now? F is mg sin theta plus mu mg cos theta. Okay, and that will be 3 times of the force that is preventing, which is this mu mg cos theta. Okay, first of all we can cancel mg throughout. Yes, then we'll have mu 3 mu minus mu cos theta, so that is, I think, 3 minus 1, that is 2 mu cos theta. So sin theta upon cos theta, that is tan theta. and mu, 2 times of mu. So if I multiply 2 over here, okay, that is 1 by root 3, 10 of which angles is 1 by root 3, I guess 30. Okay, 1060 is root 3, so 1030 is 1 by root 3. Yes, so 30 is the correct choice over here. Okay, I hope you were able to understand this. So let's move to the last two questions for the day, which will be your homework question, and you'll let me know the answers of those questions in the comment section. So question 29 and 30 over here, these are the last two questions. These are also your homework questions. You'll do them and let me know the answers in the comment section. The correct answer, of course, receives a heart. Okay. So yeah, here I'll explain you a bit. Here we have two charges at distance A and minus A. This is the origin, okay, midpoint. Here we are going to bring another charge Q by 2, okay, and we are going to move it x distance away from this point. Okay, we are just going to move it away x distance away. X is pretty much smaller than A. You're supposed to tell what will be the kind of motion that this charge will exhibit. Will it be SHM? Will it remain stationary? Will it be oscillatory motion, or will it be a projectile motion? Okay, actually it's very simple. You just have to calculate forces, move this distance x, calculate electrostatic forces over here, calculate electrostatic forces again, find the difference in the forces. You will find that force is proportional to something, and that will point out to something. Okay, yes. Now let's come to question number 30. Again, it's a straightforward question. Okay, everything is given. I need not explain it. Yeah, so that's all from today's class. I hope you enjoyed it. If you did enjoy it, smash that like button, really means a lot to me. Consider subscribing if you want to continue with the grind. Okay, and that's all. Yeah, and keep enjoying physics.